Today we are on Unit 12, Lesson 6, Mixed Probabilities. We'll be covering pages 429 to 431. I'll be using colored pens, so that's optional, and you also want to have your calculator for simple operations, adding, subtracting, and dividing. So in summary, basically this is just practice with all our different formulas we've learned in this unit. So our summary of, for any event A, the probability of not A equals 1 minus the probability of A. Remember, the symbol for not is the tilde. Probability of not A equals 1 minus the probability of A. And this also keep in mind that the probability of A plus the probability of not A equals 1. For any two events, A and B, the probability of A given B, probability of A given B, that's its notation, is equal to the probability of A and B, and symbol looks like this N, divided by the probability of B. Events A and B are independent if and only if the probability of A and B, it's just helpful to write it, so it'll help you to memorize it, is equal to the probability of A times the probability of B, or if the probability of A given B equals the probability of A. And let's not forget, way back in the beginning, the probability of A or B is equal to the probability of A plus the probability of B minus the overlap, the probability of A and B. Our first exercise, given that the probability of event B occurring, given event A has occurred, is the probability of B given A is equal to the probability of A and B divided by the probability of A. Answer the following. Rewrite the formula solving for the probability of A and B. So in other words, here's the probability of A and B, but right now it's being divided by the probability of A. So let's simply multiply both sides by the probability of A. And I'm just going to write our right-hand side first, so probability of A and B, just swapping the right and left-hand sides, is going to equal the probability of A times the probability of B given A. How could we write this formula if events A and B were independent? Well, let's say, if A and B are independent, then the probability of B given A would have to equal the probability of B. So we replace probability of B given A with the probability of B. So we would have the probability of A and B equals the probability of A times the probability of B. Exercise 2, the results of a survey of the student body at Kingston High School about television viewing preferences is shown. Are the events student is a female and student prefers reality series independent of each other? So student is female, and I'll use reality series, R, for reality series. Are they independent? Well, this is where we have choices we can make. They're independent if the probability of female given reality series equals probability of female, or the probability of prefers reality series given female equals the probability of prefers reality series, or the probability of female and reality series equals the probability of female times probability of reality series. So you can choose any one of these three ways to prove whether or not, or to show whether or not they are independent. Right? So I actually might do all three. Female given reality series. So given reality series, we know that reality series is our denominator, which is 180. And of those 180, 110 were female. The probability of female is 260 out of 490, the total 490. So 260 over 490. Are they equal? $110 divided by 180. And it's 0.61 repeating. And 260 divided by 490 is 0.5, approximately 0.5306. So no, they are not independent. If I had gone with probability of reality series given female, so given female, 260 is the denominator. Of those reality series, 110. Does that equal probability of reality series 180 over 490? $110 divided by 260 is approximately 0.42. I'm just going to round to hundreds. Does that equal 180 divided by 490? Approximately 0.37. That's no. And probability of female and reality. So female and reality is 110 over the total, 490. Does that equal probability of female, which is 260 over 490, times probability of reality series is 180 over 490. So 110 divided by 490, approximately 0.22, and 260 divided by 490 times 180 divided by 490, 0.19. Again, you only need to show one of these. You don't have to show all three. Exercise 3, the results of a poll of 200 students are shown in the table. For this group of students, does the data suggest that gender and preferred music styles are independent of each other? Justify your answer. Okay, so there's so many different ways we can do this. I'm just going to choose one. I'm going to say independent if the probability of, let's say, female, I'm just going to take the first one, female given preferred music is techno, does that equal probability of female? Female given techno, so we're just looking at techno is our denominator, and we need the total there, which is 90. And of those, 54, so does 54 over 90 equal the probability of female? We need a total here. Well, there's 200 students as a total. but how many are female? 54, 25, 106. 54 divided by 90, 0.6. And 106 divided by 200, 0.53. No. You're not independent. Exercise 4, we have a credit card company states that 42% of its customers are classified as long-term cardholders, 35% pay their bills in full each month, and 23% are long-term cardholders who also pay their bills in full each month. With the event that a randomly selected customer is a long-term customer or cardholder BL, so this is L, and that's its probability, and the event that a randomly selected customer pays his or her bill in full each month, BF. This is F. What are the values of the probability of L, the probability of F, and the probability of L and F? All right, so the probability of L is 42%, which I'm going to write as a decimal, 0.42. The probability of F is 0.35, and the probability of L and F is 0.23. Draw a Venn diagram or a two-way table. So we have a choice here. I'll do both. I'll do Venn diagram first. We have long-term, and then we have pay in full. Long-term probability is 0.42, pays in full 0.35, and the and is 0.23. And oftentimes when this is the case, I'll just kind of continue with, right, so if I know that, then if this portion of circle L is 0.23, then 0.42 minus 0.23 would give me the other piece of this, which would be 0.19. And 0.23 plus what would give me 0.35, 0.12. The OR, right, this is OR, would be this, which is 0.42 plus 0.12, 0.54. Okay, so we did more than what it asked for. Now for the Venn diagram, for the two-way table, we have pay in full and not in full, and long-term and not long-term. And we have our totals at the end. Okay, long-term is 0.42. Pay in full is 0.35. And the and, long-term and in full was 0.23. And we know that this has to be 1.00. 0.23 plus 0.12 would give us the 0.35. 0.35 plus another 0.65 would bring us to 1. 0.42 plus 0.58 would bring us to 1. And 0.23 plus 0.19 brings us to 0.42. And 0.12 plus 0.46 brings us to 0.58. Use the conditional probability formula to calculate the probability of L given F. Right. probability of L given F is going to equal the probability of L and F over the probability of F, right? The denominator is the probability of F. L and F is 20.23 and F is 0.35. And we want to the nearest thousandths, that's 4 decimal places. 0.23 divided by 0.35. 0.657, oops, 3 decimal places. 0.657. Use the condition probability formula to calculate the probability of F given L. The probability of F and L divided by the probability of L. So F and L hasn't changed. That's the same as L and F. 0.23. Probability of L is 0.42. And rounding to 3 decimal places, 0.548. Which is greater? Probability of F given L. Probability of F given L was 0.548. And the probability of F is 0.35. So the probability of F given L is greater. This tells us that long-term cardholders are more likely to pay their bill in full each month. This tells us long-term cardholders are more likely to pay their bill in full each month. Than, let's say, the general customer. Remember that two events, A and B, are said to be independent if the probability of A given B equals the probability of A. Are the events F and L independent? Independent if the probability of F given L equals the probability of F. F given L was 0.548, and the probability of F is 0.35. Our answer is no. They are not independent. Okay, we are 20 minutes in, almost 20 minutes into the video, so I'm going to stop there. We'll end here, and we'll pick up in class. Thank you for your attention.